In this lesson, we're going to learn how to solve a system of equations by using a process known as substitution. What exactly is substitution? Well, suppose you go to a restaurant and you order dinner. Your dinner comes with an order of French fries, but you don't want French fries. Instead, you would prefer to have broccoli. And so you ask your server if you can substitute the broccoli in place of the French fries. You took one thing, French fries, and replaced it with another item, broccoli, which is of equal value. The process is the same in mathematics. We will take one variable and replace it with an expression of equal value. Allow me to show you how that works. In our first example, we want to find the solution to the system of equations. Because we have at least one equation that has a variable alone, y equals, we can easily use substitution. We know in the first equation we have y equals 6x minus 20. In the second equation, we have y equals negative 4x. If we look at that second equation, we know that y is the same as negative 4x. Since y is the same as negative 4x, we can go to the first equation and replace the y with a negative 4x. The blue equation does say that y is the same as negative 4x after all, so we can replace that y in the red equation with a negative 4x. That gives us an equation, negative 4x equals 6x minus 20, and this is a very simplistic equation to solve. We begin by subtracting 6x from both sides, divide both sides by negative 10, and we find that x is equal to 2. We now know the x value, that is the point, or the solution, to the system of equations. But what is the y value, and how do we find it? Well, we can use either of the equations that we have, y equals negative 4x or y equals 6x minus 20, and it's up to you which equation you want to use. We'll look at both of them. If we use the blue equation and we substitute 2 in for x, we see that y is negative 8. If we use the red equation and we substitute 2 in place of x, and we do a little bit of work, we again see that y equals negative 8. So x equals 2 and y equals negative 8. That means that the solution is the point 2, negative 8. Remember, these are the values for x and y that will make both equations true at the same time. In a previous lesson, we talked about graphing. If we were to graph these lines, you would find that they intersect at the point 2, negative 8. Here's an example for you to try. Can you solve the system of equations by using substitution? Please pause the video here and come back when you're ready to compare answers. Let's see how you did. We can use substitution because we have at least one equation with x equals or y equals. In this case, both equations are y equals. The second equation tells us that y is the same as 7x. So we can go to the first equation and replace the y with 7x. That gives us the equation 7x equals 4x plus 3. Now we solve by using our properties of equality. When we do that, we find that x is equal to 1. Now we need to determine the y value. You can choose either the red or the blue equation in order to find the y value. I recommend choosing whichever is simplest. Y equals 7x, substitute 1 in place of x, y equals 7. That's the y value. Since x equals 1 and y equals 7, the solution to the system is the point 1, 7. Remember what that means. When x is 1 and y is 7, both equations will be true at the same time. If we were to look at the graph of each of those lines, we would see that those two lines intersect at the point 1, 7. And so substitution is really just another way to determine where two lines intersect without actually having to graph them. Let's take a look at another example. Here we have the equation 3x plus 2y equals 15 and y equals 6x. We want to find the solution to the system of equations, the point where the two lines intersect. We know that we have one equation, the blue equation, that is solved for y equals 6x. y is the same as 6x. So what we can do is replace the y in the other equation with a 6x. What we really have is 3x plus 2y equals 15, but we replace the y with a 6x. And now we have an equation with a single variable that we can solve. We multiply 2 times 6x, so we have 3x plus 12x equal to 15, combine like terms, and then divide both sides by 15. X is equal to 1. Now we need to find the y value. We choose the equation that's the easiest to work with. Y is equal to 6x is as simple as it gets. We substitute 1 in place of x, and we find that y is equal to 6. Since x equals 1 and y equals 6, the solution to the system is the point 1, 6. Remember, this means if x is 1 and y is 6, both equations will be true at the same time. If we were to graph both of these lines, we would see the same thing. The point of intersection is the point 1, 6. In our next system, we have something a little bit different. We don't have either equation with y equals, but we do have our first equation in red with x equals. In this case, x is the same as negative 3y plus 1. We can use substitution to replace the x in the second equation with negative 3y plus 1, since x is the same as negative 3y plus 1. That's what the red equation tells me. So I take that blue equation, negative 9x minus 10y equals negative 43, and I replace the x with the negative 3y plus 1. And now I solve the equation. I begin by using the distributive property, I combine like terms, and then I use my properties of equality to solve the equation. When I do that, I find that y is equal to negative 2. This time I found the y value, and now I have to ask myself, what is the x value that goes with that? Well, according to the red equation, x is equal to negative 3y plus 1. Substitute the negative 2 in place of the y, and evaluate. X is equal to 7. Since x is equal to 7 and y is equal to negative 2, the solution to the system of equations is the point 7, negative 2. These are the values for x and y that would make both equations true at the same time. If I were to graph both of those lines, I would find that they would intersect at the point 7, negative 2, which confirms that I found the correct solution by using substitution. The last example is for you to try. Can you solve this system of equations by using substitution? Please pause the video here and come back when you're ready to compare answers. Let's see how you did. We look at our equations and we see that the red equation is solved for y. Y equals 6x plus 2. Y is the same as 6x plus 2, so we can replace the y in the blue equation with 6x plus 2. That essentially gives us 5x minus 6 times 6x plus 2 equals 19. We use the distributive property, combine like terms, and then use the properties of equality in order to solve the equation. We find that x is equal to negative 1. Now we have to determine the corresponding y value. We use the equation y equals 6x plus 2, substitute negative 1 in place of x, and then evaluate. We find that y is equal to negative 4. Since x is negative 1 and y is negative 4, the solution is the point negative 1, negative 4. Again, we can confirm this by looking at the graph of the lines, and we see that they intersect at the point negative 1, negative 4. Negative 1 and negative 4 are the values for x and y that make both equations true. This is everything you need to know to get started working with systems of equations and solving them using the substitution method. Remember, you can learn more about systems of equations in Mr. Dorey's Algebra Handbook, available at www.doreypublications.com.